two topics, and the third topic is file allocation methods. It means allocate space to the file so that disk space is utilized in an efficient manner. Now, there are certain factors which need to be considered before allocating space to the files, and these factors are: first is processing speed of sequential or random access to the file. Second is ability to make use of multi-sectored and multi-track transfer. Third is disk space utilization, and fourth is main memory requirement. So we'll talk about all these factors one by one. So first is processing speed of sequential or random access to the file. So it is actually the processing speed in both in sequential or random access. It means, suppose if I am allocating space to a file and after that allocation my sequence or random access is too slow, then that allocation is considered to be inefficient. Now, second is ability to make use of multi-sectored and multi-track transfer. Now, whatever space you are allocating, after allocation, that files need to be capable of handling multi-sector and multi-track transfer. The third is disk space utilization. It means files need to be allocated such that maximum number of files stored in a disk. For example, if I am having a disk size 500k and one block I am having the size of 400k, and I am having one file with 390k, and I have to allocate that file to the disk. Now there are two blocks. Either I can choose 500 or I can choose 400. So if I'll choose 500k, that means I am wasting 1110k, and if I choose 400k, that means I am wasting 10k memory only. So it says choose the block in which the disk space is better utilized or in an efficient manner. Now, last is main memory requirement. Main memory requirement. Main memory is always constant in an operating system. We have limited main memory, so that file allocation should be in such a manner that main memory requirement should be less. So these are some of the factors that you need to be considered before allocating a space to a file. Now there are different kinds of allocation methods, and we will see each of those methods one by one. So these allocation methods are: first is contiguous allocation, linked allocation, and third is index allocation. So first we will cover the contiguous allocation. In this, each file occupies a set of contiguous address on the disk. So suppose if I am having a disk like this, and we have certain blocks like 0, 1, 2, 3, 4, 5, 6, 7, 8 with the block 0 to 8, and we have a file directory which is used to match that which file is stored at which location. There is a directory with a file name, starting point, and length of the file. So it says each file will contain a set of contiguous address on the disk. It means that if a file A needs to store in this file the starting as 0 in disk, and file contiguous occupies the block up to 2 block, because the length of file name A is 2. So location of file A is like this in your file, which is starting at 0 and going up to the length 2. So similarly for the file name B, its starting is 3, so block will start like this 3, and length is 3. It will cover up to 3 blocks. So this is how the contiguous allocation works. In this, linear ordering is used. Location of file is defined by the disk address. Both sequential and random access are supported. And there are two main disadvantages of contiguous allocation, that is finding space for new file. It is very difficult because to keep track for the free blocks, and second is external fragmentation. This is the biggest disadvantage of contiguous allocation. And there is a one variation of contiguous allocation is dynamic storage allocation. Now next allocation method is linked allocation. It solves all the problem of contiguous allocation. In this, each file is linked list of a disk block. It is now not necessary that we have to a contiguous address for a file to be saved. We can have scattered blocks and each block should be linked with other block, and then there is no external fragmentation. But the disadvantage is it can be used only for sequential access file, and this is the major disadvantage of linked allocation. So let us see with an example that how linked allocation works. Now let us assume that we have a directory like this where we have a file A. Starting location is 9 and ending is 13. So how this will stored in the disk with the help of linked allocation is, now we know our starting point is 9. So this pointer will be linked as this in the disk. And suppose after 9 this pointer will be linked like this, ninth block of the disk. So after 9 there is a that is linked is 4th, so it will have pointer like this. Then from 4th it can be 1, and from 1 it can be 6, and from 6 it can be 11, and so 11 will be linked to the 13. And also we will have a pointer from the directory to the disk. So that is how it works. That is linked allocation works like this. Now third one is index allocation. Indexed allocation solves a problem of linked allocation, that means no random access. The problem with linked allocation is that there is no random access, but index allocation allows random access. In this, all the pointers are brought together into one location called index block, and each file has its own index block. Now let me explain to you that how it works. Let us suppose there is a directory structure like this with the file A and index block is 9. So this is your index block, and all the pointers of this file are present in this index block. So index block will look like this. It will have all the pointers, for example say 4, 2, 3, 7. It means the file is stored at a location 4, 2, 3, 7, and the information of this is storage area is present in this block. So now after this, what happens? If I want to access the block 2, then what I need to find index block, go there, and from this I can directly access the second block. So that is how it solves the issue of random access, which is the disadvantage of linked allocation. So these three are the file allocation methods by which we can allocate the files in operating system. So now next topic is free space management, that is the last topic in operating system. So free space management, free space list is a data structure which is used to keep track of all free disk blocks. As we see, there are certain blocks which gets allocated, and once the file works is completed, that block also gets freed. For this we need to know about free space management, so that we could get to know which block is free and can be allocated to the new file. So for this purpose, free space list is a data structure which is used to keep track of all free disk blocks. For example, I have created sample of free space list just for the explanation purpose. Now if there is a file X of 150k and I have to allocate a space from this free space list. So what happened, this X will start seeing the space from this list, or the system starts seeing the space to allocate space to this file X. So let us say a 100k smaller than this, it cannot be allocated. Then we have B, this is 200k, so we allocate this B to X and remove this entry after allocation. So now the new free space list is A 100k, C 300k and D 400k. B entry will be deleted. Let us assume that there is one file Y which is having a space location E of 500k, and this file is now deleted. Now this space will be free, this file will be deleted. So what the system will do, system will create the new free space list like this: E 500k, A 100k, C 300k and D 400k. This is how free space works. It can be implemented in two different ways: bitmap or bit vector. And this single bit is used for representing state of block. So if the bit is 0, so if the block is allocated, the bit is 0, and if the block is free, this is allocated as 1. So for example, a disk having blocks 2, 3, 4, 5, 6 and 8. So how I will represent in the form of 0 and 1? So let us consider 0 to 9. It means block 2, 3. So first one block 0 is free, so here I will write 1. 1 is free, I will write 1. 2 is in A, I'll write 0. 3 is in A, I'll write 0. 4 is allocated, I'll write 0. 5 is allocated, I'll write 0. 6 is allocated, I'll write 0. 7 is free, I'll write 1. 8 is allocated, I'll write 0, and 9 is free, I'll write 1. This is the free space can be implemented. This is the way by bitmap or bit vector the free space can be implemented. Now the second approach is to link together all free disk blocks. So for example, if I am having a disk like this, the approach is to link all the free blocks. There will be a pointer in free space list that will point to the first block of the list. That is how you can implement your free space management, by linking together all free disk blocks. And this video will cover two topics of Unit 4, that is file allocation methods and free space management. And